Hello students, in this video we'll see an example of how to compute the covariance of two random variables given their joint PDF. If we're given two random variables x and y with joint PDF proportional to x plus 2y, where x is between 0 and 1 and y is between 0 and 1, we wish to find the covariance of these two random variables. Find the covariance of x and y. Well, we need to find what the PDF is, so we'll find the value k by doing the integral from 0 to 1, the integral from 0 to 1 of k times x plus 2y, and we'll do a dy dx or dx dy, doesn't matter. This will be equal to k, the integral from 0 to 1. I'll do a y integration of this. I'll have an x times y, and a y integration of 2y is just going to be y squared, and y goes between 0 and 1 dx. So this will be k, the integral from 0 to 1 of x plus 1 dx. Now, x integrates to a half and 1 integrates to 1, so this is going to be 3 halves. So we have k times 3 halves is equal to 1, so k will be equal to 2/3. So this k over here is 2/3. Now, we recall that the covariance of x and y is the expected value of x minus the expected value of x, y minus the expected value of y. And this is the expected value of x times y minus the expected value of x times the expected value of y by an algebra calculation. So there's three things to compute here. We first compute the expected value of x. The expected value of x is the integral from 0 to 1, the integral from 0 to 1. And since I'm doing the expected value of x, I put an x here and then the PDF. And the PDF we found to be 2/3 times the quantity x plus 2y. And we can do a dy dx or dx dy, doesn't matter. We'll do a dy dx. So this will be the integral from 0 to 1. I'll pull that 2/3 out of the integral. And then I'll have an x squared with respect to y. That'll be x squared times y. Then I'll have an x times 2y. That will give me an x times y squared. And then y goes between 0 and 1. And then I'll do a dx. So this will be a 2/3 integral from 0 to 1. Then I'll have an x. So when I plug in y equals 1 to this formula, I'm going to have an x squared plus x. When I plug in y equals 0 to the formula, I'll get 0. So I'm just going to have x squared plus x dx. This will be 2/3. The x squared integrates to a third. The x integrates to a half. And so we see that this is going to be 5/6. So I have 2/3 times 5/6. So the 2 will cancel the 6, will get 3, so this will be 5/9. So that's the expected value of x, is 5/9. The expected value of y, we'll find in a similar way. It's the integral from 0 to 1, the integral from 0 to 1 of y now instead of x, and then 2/3 x plus 2y dy dx. I'll pull that 2/3 out. I'll have the integral from 0 to 1. If I do this x times y with respect to y, I'll get x y squared over 2. If I do 2y squared with respect to y, I'm going to get 2/3 y cubed. Y goes between 0 and 1. Then I'll have a dx. So this will be 2/3. And then the integral from 0 to 1. And when I plug in y equals 1 to this, I get x over 2 plus 2/3. X over 2 plus 2/3. When I plug in y equals 0, I get nothing. So I just get a dx. So this will be 2/3. And then x over 2 is going to integrate to a quarter plus 2/3. So that's 11 over 12. So this is 11, so 2/3 times 11 over 12. And so that's going to be a 6 in the denominator, so I'm going to have an 11 over the 2, that turns into 6, so 11 over 18 is the expected value of y. And finally, we'll compute the expected value of x times y. The expected value of x times y is the integral from 0 to 1, the integral from 0 to 1 of x times y times 2/3 x plus 2y dy dx. So this will be 2/3, the integral from 0 to 1. And then I have an x squared y with respect to y. So that'll be x squared y squared over 2. Then I have xy times 2y. So that will be a 2/3. Then I'll have an x and a y cubed. Y goes between 0 and 1. Then I'll have a dx. And so this is 2/3 the integral from 0 to 1 of x squared over 2 plus 2/3 x. So I have x squared over 2 plus 2/3 x dx. And so continuing this calculation, this is 2/3. And then this x squared over 2 will integrate to a quarter. This will integrate to a half, so this will integrate to 1/3. So this is 2/3 times 7 over 12. So that will be a 7 over 18. So finally, our covariance is just the difference of these things. So our covariance of x and y will be the expected value of x times y, which is 7 over 18, minus the expected value of x times the expected value of y. So minus 5 over 9 times 11 over 18. And that's our solution. Thank you very much.